Let's explore log-structured file systems, a write-optimized file system design that is particularly well-suited for modern storage technologies. A log-structured file system is a file system that structures all data as a continuous log, optimized primarily for write performance. It treats the storage as an append-only log where all modifications are written sequentially, enhancing the speed and efficiency of write operations. Now let's compare traditional file systems with log-structured file systems. Traditional file systems use an update-in-place design, which provides fast read access but results in slower write speeds due to the seek and update operations. The I/O patterns are more random. In contrast, log-structured file systems use an append-only log design, offering faster writes through sequential appending. However, reads can be more complex, often requiring index lookups. This system benefits from sequential I/O patterns. Examples of traditional file systems are Extension 4 NTFS and FAT32, whereas log-structured file systems include LFS, F2FS, and NILFS. There are 4 key principles of log-structured file systems. First, all writes are sequential, meaning data is written to the end of the log in a continuous manner. Second, files are organized as segments within the log, which helps manage data efficiently. Third, an index maps file locations to log positions, enabling the system to quickly locate data. Fourth, garbage collection reclaims space from obsolete data, ensuring the storage remains optimized by removing outdated information. Here are the steps for write operation in log-structured file systems. Initially, data is collected in a memory buffer, forming a segment. Once the buffer is full, the entire segment is written sequentially to the disk, ensuring efficient write performance. The file index is then updated to point to the new data location, allowing for quick retrieval. The old data becomes obsolete and is marked for garbage collection to free up space. Finally, checkpointing ensures that the index is durable, preventing data loss. Let's look into how read operation happens in log-structured file systems. When an application requests to read a file, the system consults the in-memory index to locate the file's data. The index provides the segment location and offset within the log where the data resides. The data is then read from the specific location in the log and returned to the application. The index maps the file's inode to the segment location and offset, facilitating efficient data retrieval. Garbage collection is an important part of log-structured file systems. As files are updated, old versions become obsolete, but still occupy space in the log, leading to storage inefficiencies. To solve this, the cleaning process involves identifying segments with the most obsolete data, reading the live data from these segments, writing the live data to new segments, and reclaiming the old segments as free space. Cleaning policies include cost-benefit analysis, which balances utilization and age, and hot or cold separation, which groups data by update frequency. This process ensures that storage space is used efficiently and performance is maintained. Let's understand the advantages and challenges of log-structured file systems. One of the primary advantages is the fast write performance, which is due to sequential writes. It also offers reduced power consumption because of fewer disk seeks. These file systems are efficient for solid-state drives, reducing write amplification and providing fast crash recovery through checkpointing. Also, it provides built-in versioning capability. However, there are challenges. Read operations are more complex and require index lookups. Garbage collection introduces overhead during system idle time. Performance degradation can occur when disk space is nearly full. Managing the index for large file systems adds complexity, as does the overall implementation when compared to traditional file systems. Several real-world implementations reflect the practicality of log-structured file systems. Sprite LFS was the original research implementation that pioneered the log-structured approach. F2FS, or Flash-Friendly File System, is optimized for NAND flash storage and is widely used in Android devices. NILFS2 is a new implementation of log-structured file system for Linux, offering continuous snapshotting capability and strong crash resistance. In conclusion, log-structured file systems represent a paradigm shift in storage design, optimizing for write performance at the cost of more complex reads. They are particularly well suited for modern storage technologies like solid-state drives and are increasingly relevant in today's write-intensive applications. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.